Welcome everyone. In this video we are going to talk about 7 segment display on FPGA board Basys 3. On Basys 3 we have 4 7 segment displays and we can display different numbers as well as same numbers on all, or we can also choose that I am going to display only on one of the displays. So in this experiment we are going to display a number only on one of the 7 segment displays. Our experiment is we are going to take input from 4 switches, which will be a hexadecimal number, and the hexadecimal number will be shown on this 7 segment display. So if I show here 0 0 0 0, 0 will be showed, and if I show 1 0 0 0, that means 8, so 8 will be displayed. So we create a design source. Seven underscore seg. We need 4-bit input, so I can call it anything like LED input. This is 4-bit. Then for 7 segment display we need to understand how to display the output. 7 segment display is a combination of 7 LEDs, which are A, B, C, D, E, F and G is here. So now if I want to display 0, I will make these 6 LEDs glow and will keep this off. How to keep them on and off? There are two ways. One is common anode, common cathode. This is by manufacturing. The LED which we have on Basys 3 board is common anode. That means the P side of each LED is connected to common voltage 3.3 volt. So on this side, if I give logic 1, 1 and 1 will not make a voltage difference, so this will be off. And if I make logic 0 here, 1 and 0, so the current will flow, so this will be on. That means if I want to glow a particular LED, I should give input 0. If I want to switch off a particular LED, I should give input 1. So I need 7 outputs or 7-bit output, plus I need to mention out of 4 7 segment LEDs on which I want to show the output. So we need 2 output variables. One is seg, which is 7-bit, so 6 down to 0, and one is an, which is called anode activate. It is a 4-bit number. So we take our 7 segment as top module, we take our 7 segment as top module, and we come back to coding. In this we are also going to learn a new coding style in behavior coding, that is case statement. So we are going to put a simple case. This table describes the relation for a common cathode 7 segment display. So if I want to display 0, my input will be 0 0 0 0. So LED number A, B, C, D, E, F, these will be on, G will be off. So A to F, they are on, G is off. For a common anode, which is our Basys 3 7 segment, we will keep this 0 0 0 0 0 0 1. Similarly, if you want to display 1 means only B and C should be on. To keep B and C on, here we give 1, but in our code we are going to write 1 0 0 1 1 1 1. So this way, for all 16 cases, we are going to write the cases. So here we start a process. This process is sent on LED input, begin, end process. Then we say case. The case is dependent on this variable is. This is the syntax for starting the case. Then we say when. Now LED input is a standard logic vector of length 4. When I value, I have to keep it inside double quotes. So when it is 0 0 0 and then you put equal to greater than sign, that means after this symbol whatever we write, it will happen in case whenever LED is 0 0 0. So when it is 0 0 0 0, what we are saying, that segment 7-bit segment value, it should be 0 0 0 0 0 6 times 0 and then 1. This is also a standard logic vector, so it should also come in double quotes, and that is. Now we can write the second code. When 0 0 0 1, then seg is equal to B and C are on, all others are 0. So this way I have already written the code, so I'll just take it, and for all 16 cases we have written. So make sure that you have written it for all 16 cases. Sometimes what can happen, that you have 4-bit input, so 16 cases will be there, but you know the answer for only 10. For others cases, then what we do, we say when others, and we can write the condition that in this case this should be the output, or what should happen. So once we write all the cases, then we can say end case. We have not mentioned anything about anode activate. So if I want to display my output on this one, then I will keep this as 0, all others as 1. So we will simply write an is equal to. So this is our code for 7-segment display. Now we can create the XDC file also. I have purposefully taken the name seg and an because when I go to the blank XDC file for Basys 3, now my input is LED in. So I am going to take first 4 buttons, first 4 switches, and these will be used as my 4 inputs. Now I come down to 7-segment display. These are the 7 ports which we have for 7-segment display. So now what we see, my name is seg, and in XDC file also the name is seg. So I don't have to write anything, I just remove the comments and it is ready. Similarly for anode activate, I don't have to write anything, it's already done. This DP is for the point which we have. We are not glowing the point right now, so we leave it. Now there is one more thing which we need to change. Look at this. This is A on the MSB side and G on the LSB side. If we look at our code, this is 6 down to 0. That means this is MSB and this is LSB. When we come to, so this is fine. This is A, B, C, D, E, F, G. This is okay. When we come to the 7 segment, the first one, which is G here, is coming here at the first. A, which is MSB, is coming here. But what we want to display, A here, G here. So we have to reverse this order. So this should be 6, this should be 5, this should be 4, 3 will remain 3, 2, 1 and 6 will become 0. So these are the changes. Once we save this, then you can continue, you can compile it, and that will be all.